Hi there. In this video, I am going to go over time travel and multiple timelines. This is an important and delicate, complicated issue. It's a big step in shift from thinking of time as a single linear, continuous thing. Okay, so let us review the ancestor paradox. In classical thinking of time as a linear, continuous thing, we'll have point A and point B on a timeline. And a person at point B in the history of their timeline becomes dissatisfied with life and wants to go back to point A and kill one of their ancestors to prevent their own existence from coming about. Okay? So they go back in time to point A and kill the person who would become their ancestor, before they did so. And thus they prevent their own existence from coming to pass. However, the paradox is that since they have traveled back in their own history, the history of their own timeline, of their own universe, and killed the person that would have become their ancestor, how could they possibly exist then to be able to go back in time and kill their own ancestor when they have already prevented the creation of their own existence? This is, they call it the grandfather paradox. I like to call it the ancestor, generalize it and call it the ancestor paradox. And modern thinking on time travel has a solution for this paradox, resolves this paradox. A lot of TV movies have been made on this thinking. The most recent one is Looper. And numerous TV series have included this ancestor paradox. So let's see, one here, classic ancestor paradox. Okay, now the solution to this still retains the linear time paradigm, although it states that it holds that time travel back in one's own history, the history of one's own timeline, is impossible. That time is a point of zero length, and that to travel back in the grander scheme of time, one needs to travel back to the present of a parallel universe that is further upstream in time. They call it a parallel universe because it's similar. The same planets exist in a much similar way. The organization of this parallel universe is similar to the one the original chrononaut leaves. It also kind of presumes something about time in general, that time flows like a river. Streams is a streaming thing. and the stream has a rate of flow, and that universes are intimately anchored into points of zero length that along this river of time, and these points progress through time at a fixed rate, and the rates of any two parallel universes progressing through time are the same, so they progress with a fixed distance between them, and that if one is able to escape from their universe, their original point in time, their anchor point in time, and travel back to an earlier time, they actually travel to another universe, a parallel universe that is further upstream in time from where they were. And we see here they call this an independent timeline. The sequence of events, the sequence of historical events in these two timelines are independent. So if you change an event in timeline A, that doesn't necessarily change anything in timeline B. Independent timelines. So that'll be our point here too. Independent. Timelines. So the person from timeline B travels back in time through the grander river of time, and they have to drop into the present of a universe, or the present of a timeline, in order to experience reality. So they drop into timeline A and kill the equivalent of their ancestor in timeline A. So let's move this here to here. In timeline A. Now, what they have done, since obviously they still exist, they haven't ceased to exist because they didn't actually go back in their own history and kill their own actual direct ancestor in their timeline. They've gone back to a different timeline and killed the equivalent of their ancestor in that timeline. When timeline A gets to the point in the grander scheme of time where B was, we'll call this A1, A prime. B will now have moved the same amount of time to B prime. We would see that their equivalent self in timeline A has been prevented from coming into existence. But the original person from B, if they remained in timeline A, is still there. Well, that would be more than one lifetime. But the person from B would still continue to exist after they killed the equivalent of their ancestor in independent timeline A. So that is how the ancestor paradox is resolved through the use of independent timelines. There's another interesting consequence to the use of independent timelines, and that consequence is the direction, time travel in the forward direction of time, in the upstream direction of time, also it becomes possible. So there was a classic limitation, constraint upon the direction of time travel And that, in the classic way, if we have point A, B, and C, if a person, and this is going to be linear time, and all refer, points A, B, and C all refer to the same timeline. Now, drawing out timelines this way is the intuitive way. If you have points on the same line, you're talking about points in the history of the same timeline, the history and possible future of the same timeline, drawn out in a linear way, as if time was a hall that you could, walk up and down in, which it's very different. Actually, time, we'll get to that. Time is very different. Time is actually a point. It's not of zero length. It's rather than a line. The present, we can say that the present is a point of zero length. And one can never travel, and one always has to be in the present in order to experience reality, material reality. Alrighty. So, time travel in the backwards only direction, in the upstream direction, has classically been the only direction time travel that has been considered to be possible. Because in order for the present to get to be, it must have passed through all the time preceding it, creating events, creating a history that then can be traveled back to and experienced. Okay? Now, travel in the forward direction of time has been considered to be impossible because that history, that sequence of events, has yet to be created. So the only thing, so that the future exists only as possibilities of the outcome of events in the future. There's no physical existence to the future yet because it has yet to happen. So traditionally, travel into the future of one's own timeline has been thought to be impossible. Okay. So, the classical limitation is backward travel only. Gee, I just right here. Okay. Backward time travel only. Classical constraint on time travel. Now, when we change our view to include multiple timelines, multiple independent timelines, remember, time is the grand, this bottom line I'll always consider, I should probably draw it different. Let's put 2 arrows here. 2 arrows will represent the river of time itself, the grander flow of time, the grander, whatever you want to call it. So we'll have point B. Oh dear. How should we do this? I have point A. I have point B. And these are presents. Different presents, the present, in different timelines, where the present is anchored to a different spot in the river of time, and all of these spots progress in the river of time, flow of time, with a fixed distance between them. They all progress in unison. And these are all independent timelines. So now, in order to resolve the ancestor paradox, we've created the independent timeline for travel in the upstream direction of time. Allows a person to go back into a similar parallel universe and kill the equivalent ancestor of themselves in that universe and prevent the existence from coming into being of their equivalent self in that parallel universe when that parallel universe gets to an equivalent time from which the time traveler left their own universe, their own timeline. It gets confusing when the terminology has to be kind of standardized here when you're talking about timelines. I probably ought to call these timelines, but independent timelines, but they're actually serial universes. Perhaps I should explain that at the end. I guess I'll just continue to call them independent timelines here to maintain some kind of continuity. Okay, so this is how the ancestor paradox was resolved, by considering when a person travels back in time that they travel to another independent timeline, to a similar universe that they left, but that universe is independent of the one that they left. This creates the possibility that the original traveler could also travel forward in time to the present of another similar universe that is anchored downstream in time from the timeline that they left, from the universe that they left. So now, independent timelines resolves the ancestor paradox and also resolves the backwards time travel constraint. Neat stuff, huh? Now, I'm going to get to the reason for this video. Well, one of them was to draw out independent timelines on multiple lines like this. And another reason was, if you have ever listened to Andrew Basiago's accounts of Project Pegasus. Project Pegasus was supposedly a big United States project into time travel and teleportation. Andrew Basiago was inducted into that program as a child, and reportedly, he did multiple excursions into the history of time, in American history, going back in particular to Lincoln's assassination and Gettysburg Address, the time of Lincoln, to observe events, then come back to the present and report what he had seen. There were other people involved with Project Pegasus, and a number of people, probably 100 or so, I think is the number. And one of the interesting things they reported when traveling into the past, particularly around the time of Lincoln and Lincoln's assassination, is that every time they would go back in time, they would send a different person back in time, or the same person back in time on multiple occasions, that they would report there were small differences in when they watched like Lincoln's assassination or when they were at the Gettysburg Address, that sometimes Lincoln was, shot by a person that appeared one way, or the person appeared differently, or he was not shot in the head, he was shot in the chest, or I think on one occasion perhaps he wasn't shot at all, he died of a medical problem. So there are differences in the timelines, slight differences, but they all resulted basically in Lincoln's death. So how could they justify, how could they explain these differences? And I think it's one of the reasons why they stopped sending people back to Lincoln's, the time of Lincoln. But undoubtedly, if we continue along this line of thought, undoubtedly with military application, they would have tried to send somebody back to assassinate an undesired person, and the assassin, would come back to the present and report the success of the operation, but the present would not have changed. So how could this be? I'm sure they've tried that. If they were able to send somebody back to observe Lincoln's assassination, I'm sure they've tried to send somebody back to assassinate an undesired person. So how can this be? Well, it just so happens Andrew Basiaggio's accounts of when they go back to the same time in history on different occasions in the future, they are sent back to the same time in history, they observe a different sequence of events. This observation agrees very well with the concept of serial universes and multiple timelines. So, independent timelines. So we draw a number of independent timelines. And the grander scheme of time itself. Now, we'll have point P, let's call this point P for the present, our present. This is the original timeline that they send people back in time. And we'll have point A here, point B here, point C here, point D here, point E, and point F. All these times, oops, oh gee, okay. In the grander scheme of time, we'll say that Lincoln's assassination happened here, in the grand scheme of time. We'll call this TX. I mean to locate TX in the middle of this cluster of points. Okay, this is the moment of Lincoln's assassination. Now I want TX, Lincoln's assassination, to be slightly ahead of these points, these cluster of points. So they send a person from the present, from point P, back to one of these points in time. This is presuming that the technology of time travel to send somebody in the past is a little inaccurate, so that when they send somebody back in the past, they don't get the same exact point in history, which is to say they don't get the same timeline. They don't get the same independent timeline. So whenever they send somebody back into the past, so the timelines, in the concept of serial universes, the serial universes are aligned in the grand flow of time like a train, one car behind the other, a series of pearls. And there's a very small amount of time between any two adjacent timelines. Now, small being on the scale of a Planck time unit, very super small, amount of time. So that when they send a person from the present back in time to, say 3 hours before Lincoln's assassination, there is an enormous multitude of timelines where the traveler could end up being on. And the theory of independent timelines holds that the events in each of these timelines is independent. So one would expect differences in the sequence of events in each timeline. They would expect that the events generally would have the same result, but specifically there would be differences in each timeline. So when the chrononaut, ended up on different timelines, it would be expected that there would be differences in the events that they observe. Okay, so there, that's a goodie. That's a good one to mull over. Now, I can elaborate a little on this. Serial universes. Okay, I'll do this as simply as I can. Serial universes. In the grand scheme of time, and we're going to use just a small interval of the grand scheme of time, we have serial universes that are spread out in time as matter is spread out more or less evenly through space. And the distance between any two adjacent serial universes is fixed, and all of the serial universes progress through time at the same rate, so that the distance between any two serial universes remains constant. Now, I expect double arrow grand flow of time as opposed to the flow of time in any particular universe. Double arrow. Grand flow of time. Now, this distance here, I expect, will be related to Heisenberg's uncertainty principle. A very important concept, which describes the breakdown in continuity of time and space once a certain limit in the scale of measurement is passed. And this is going in the small, decreasing scale of measurement. Once the decreasing scale of measurement passes a certain threshold, the continuity of time and space breaks down. And Heisenberg's uncertainty principle describes exactly how that continuity breaks down. So the separation of serial universes along the grand flow of time can be considered the space in between as a breakdown in the continuity of space and time. So that the existence of serial universes spread out through time is a consequence of the same mechanisms described by Heisenberg's uncertainty principle. For an important thing, Heisenberg's uncertainty principle. Okay, so related concepts here, issues were 5, Project Pegasus, Andrew Basiago, and the accounts of variations in history. Well, I explained, these are accounts of variation in history that chrononauts, accounts of variations in chrononauts, accounts of variations in chrononauts observations. Okay, those are the points I wanted to make in this. Breakdown in the continuity of time and space below a sufficiently small scale. Right. That is Heisenberg's uncertainty principle, and accounts for the separation of independent serial universes spread out evenly through time. Okay, I hope that gives you some interesting time of deep contemplation. Thanks for watching, and I'll see you next time.